So thank you very much for the introduction and for receiving me here. My name is Geoffroy Gauthier. I'm a calculations engineer in heat transfer, and I work for the Danish consultancy company PlanEnergi. But today I'm also here to present an IEA task where I'm subtask manager. Which is about large thermal energy storages for district heating. So let's move on. Why do we need to focus on large thermal energy storages and why especially for district heating? The first, and it's been mentioned several times in previous presentations today and yesterday, there is a high renewable energy target for the energy transition. And it's been also said earlier today, heat is half of the world energy use. It's true today and it will be still true tomorrow. And heat is also easy to produce. It can be stored at very large scale. So we're talking about gigawatt hours over long periods. Seasonal storage is something that actually works, and it's quite inexpensive at large scale. And yet it's hardly known, developed, and invested in. So just to give more arguments about my speech, I'm saying that heat is inexpensive to store, but how inexpensive? Well, it's from €4 per kilowatt hour to less than €1 per kilowatt hour at large scale. If we compare this with pumped hydro storage, it's between 100 and €200 per kilowatt hour in good cases, and on average 175. So you can see the difference in investment costs here, and the bigger the better. So as you can see on this curve, when you have household thermal energy storage, it's quite expensive, specific price. But then when you go up to a very large scale, then it's very inexpensive. Now, thermal storage enables renewables. It provides more flexibility in district heating systems. It helps reaching a higher share of renewables by such as solar. So on the right-hand side here, I'm not sure if you can see my cursor. No, I cannot see. But anyway, on the right-hand side, you can see here that we can store heat in the summer where there is low heat demand, and then reuse this later on during the year. It can be used also for peak shaving, power to heat, such as sector coupling, and a large variation of operational conditions. So it can be used for short-term, long-term, and middle to large district heating systems. Now, larger storages are needed to serve district heating systems and other large-scale applications, but also to reduce the specific costs of renewables. If you want to reach higher targets of renewables, then having a storage is indispensable. Now, why is thermal storage less known? I'm giving a lot of advantages here, but it's less invested in, it's less a hot topic. Well, first of all, it's often coupled to district heating or big infrastructure, so the public is not really aware of it. It's more industrials and big district heating networks that have to use thermal storage. It's a local solution. So unlike electricity storage, it doesn't go through borders. It usually is at city level. There are less use cases. The cheap fossil fuels have made it possible to implement district heating systems without having the need for storage, because the energy production was cheap. But today we can see that this is no longer the case. And the last point is that it's less high-tech, so it's less of a hot topic. It's maybe less sexy, but I think we'll have to disagree on this one. This is a tank thermal energy storage, and I think it's very sexy. Now, what is IEA Energy Storage Task 39? Basically, it's an international TCP focused on large thermal energy storages. We have 11 countries and 36 institutions represented. This is the logos for most of them, but not all. And we have a lot of R&D partners and industrial partners. Now, the focus, when I say large thermal energy storages, in this task, the focus is on 4 different technologies. It's tank thermal energy storages, pit thermal energy storages, boreholes, and aquifer thermal energy storages. And they can be above ground for the tanks, but also underground. And the heat transfer medium is water or soil. The volumes are more than 10,000 cubic meter. And the applications are variable. It can be daily, weekly, or seasonal storage for district heating and industries. Now, within IEA Task 39, we have 4 subtasks, and it's almost perfectly poetic. Subtask A is for application scenarios and concepts. In this subtask, we make a list of projects, list of KPIs, use cases, typical implementation procedure, and techno-economic analysis. Subtask B, that's where the poetry sense goes a bit off. It's for materials database, test references, and also water treatment guidelines. Now, C is for simulation models. It's a list of tools and models that will come out of this. It's modeling guidelines and reference as an outcome for this task. And it's for large thermal energy storages for more than 50,000 cubic meters. And lastly, D is for dissemination. And here we have assessed the information need for various target groups. We have identified 14 countries so far. If your country is not located, is not represented here, then please do contact us, and then we'll make sure that the distribution also comes to your country. And the idea is to share the results in forms of leaflets, and there will also be an upcoming workshop. Now, as I mentioned earlier, I'm responsible for subtask D, and our idea is to develop tools, references, and methods to guide large thermal energy storage projects stakeholders through the process of implementation. And in implementation, there are 4 essential phases where we have identified 3 target groups. The first target group is policymakers. The second target group is researchers and engineers. And the last target group is project developers. And a typical large thermal energy storage project takes place in 4 phases. The first one is the opportunity phase, and we'll have deliverables for that phase, which is project examples, business cases, and a list of KPIs. There is design and tender phases that come afterwards. In the design, we will provide modeling guidelines, and for both phases, we will provide methodology for techno-economic design and a materials database. And finally, there will be the implementation part that will be covered with the task. And we will provide, for example, live and historical data of large thermal energy storages. Now, the current dissemination material that has been planned for policymakers, and that's one of our main target groups, I would say, is a 1-pager description of these main steps for project development, a guide to answer the main questions that arise when having to implement large thermal energy storages. Again, the idea and the focus we have in this task is to try to make the knowledge of large thermal energy storages accessible. There has been a lot of presentations previously that have been quite technical, and we think that it's important to act now if we want to manage the energy transition. And in order to be able to act now, we need to know which technologies are currently available and make those technologies accessible for policymakers' understanding. And that's one of our main goals. So as I said earlier, there will be project examples and a project list that is one of the deliverables of this task. This afternoon, I will also send an update email on how the task has been going. It will be mainly an introduction to the task. So if you're already attending this webinar, then you're well underway. But if you want to receive this update email, again, please feel free to contact me or your TCP leader. And then last but not least, we are to organize a workshop where we will make a meeting between policymakers and researchers. And in order to do this, we are in contact with the European Commission, and we have sent an application for a policy conference session in June, but it's not confirmed that we will have access to this yet. So again, if you're interested in knowing more, of course, I'm available. If you want any technical details, I can answer from my engineer point of view. But if you're interested in receiving some information material, then please do have a look at our website and contact your IEA Energy Storage Technology Collaboration Program delegate or directly me. And with that, I'm thanking you for your attention, and I think I should be on time. So please feel free to ask any questions.
Good afternoon. I am Takahide Tokuda from Heat Pump and Thermal Storage Center of Japan, or HPTCJ, alternate delegate of Japan in Energy Storage TCP. Actually, it's my first time to speak at the international conference, and I'm not good at English, so I'm nervous, but I'll do my best. In late January, a strong cold wave hit Japan, but in Tokyo now, the plum blossoms are gradually reaching their peak. Before starting the presentation, let me brief introduce HPTCJ, to which I belong. You can see the logo. Our center was founded in 1986 and has a history of 36 years. We are making efforts to spread heat pump technology not only in Japan, but also overseas. To achieve this goal, as part of our business activities, we participate in various exhibitions as an exhibitor, and we hold seminars to raise awareness of heat pump. Moreover, we also cooperate with international organizations. Our international activities are numerous. I'll show you this in the next slide. I will introduce the activities overseas in detail. We are cooperating with the IEA by participating in the IEA's technical collaboration programs called HPTCJ and ESTCP. In addition, in 2011, we established the Asia Heat Pump Network with 7 Asian countries, which are Thailand, South Korea, China, India, Vietnam, Indonesia, and Japan. As you can see, the 7 national flags on the bottom right. Now, I would like to present the country report of Japan. This is what my predecessor, Mr. Takayoshi Shuto, presented at the 19th Executive Committee meeting, XC 193, in Rome last May. First, this is about overview. Geographically, Japan is an island nation consisting of 6,850 52 islands of various sizes. The total area is about 378,000 square kilometers, which is close to Germany. But most of the land is mountainous. There are 108 volcanoes, and 7% of the world's active volcanoes are in Japan. The population is 125 million, but it is gradually reducing due to declining birth rate. Since the land area is long from north to south, the climate varies from subarctic to subtropical. In many areas, summers are hot and humid. Winters are snowy in northern and mountain areas. The Guinness World Records for deepest snow are also recorded at Mount Ibuki, Japan. As natural disasters, many large typhoons have landed in recent years. There are many earthquakes, and it is said that about 10% of the world's earthquakes occur in and around Japan. This is energy status. The left figure shows the primary energy supply trends in Japan. Although the share of oil is decreasing, Japan still relies on fossil fuels for more than 80% of its energy needs. Renewable energy accounts for approximately 10%, with solar and hydropower making up the majority. The percentage of nuclear power has remained low since 2011. The right figure is the percentage of final energy consumption by sector. The industrial sector still accounts for a large share, but its growth is being controlled by the strict regulations and the efforts of energy conservation. Japan has declared its goal to reduce overall greenhouse gas emissions to zero by 2050, i.e., to achieve a carbon-neutral, decarbonized society. The left figure shows a scenario for Japan's 2050 carbon neutrality. By 2030, we aim to reduce greenhouse gas emissions by 46% compared to 2013. The power generation ratio in 2030 is as shown in the right figure. The goal is to cover about 60% of the total with non-fossil fuels. This figure describes initiatives towards carbon neutrality in 2050. Further electrification and technological innovations such as hydrogen utilization, synthetic fuels, and carbon recycling are needed to achieve carbon neutrality. This is RDD information in Japan. In Japan, the New Energy and Industrial Technology Development Organization, or NIDO, oversees energy storage-related research. The 2021 research project has a budget of approximately 400 million euros for energy systems, including energy storage, and 300 million euros for energy saving and environmental technologies. The major projects related to energy storage are as shown. This is the landscape of energy storage research, mainly in thermal storage in Japan. In Japan, we organize the IEA ESTCP subcommittee to link ESTCP activities with domestic researchers and companies. Many universities and companies are participating in the subcommittee. Other major research organizations and manufacturers are as shown. I introduce major subsidies and incentives for energy storage promotion in Japan. Subsidies are available for entire systems containing energy storage, such as ZEBU and demand response. In addition, many other subsidies are set up by the government and local governments. Incentives have traditionally been set in electricity rates and the Building Standards Act. This is about market. The left figure is the number of installed thermal storage air conditioners for commercial and industrial use. As a result, the peak demand for electricity, mainly in summer, has been shifted by more than 2 gigawatts. The right figure is the installation ratio by type and capacity. In Japan, relatively small distributed types account for most of the installations. Here is data on storage batteries. The left figure shows the number of storage battery shipments from Japan is growing every year, and the cumulative capacity has reached more than 3.5 terawatt-hour. The pie chart on the right shows the market share by country. Both in vehicle and stationary applications, Japan's production volume has grown, but its market share has declined. Here are Japanese top cases. The first is the district heating and cooling system in the Sasashima Live 24 area in Nagoya. This is a redeveloped area of a former railroad freight station. The heat supply started in 2012, and air conditioning more than 250,000 square meters of total floor space, including a university, many offices, and a TV station, is provided through the optimal operation of water storage tanks, cogeneration, and solar heat collectors. As heat sources, recovered waste heat, sewage heat, and waste heat from cogeneration are used. It also provides demand response through the thermal storage tank and cogeneration. The water in the thermal storage tank can also be used as emergency water in the event of a disaster, enhancing its disaster prevention function. The second case is the demonstration test of demand response using existing thermal storage tanks for air conditioning. With the cooperation of the existing thermal storage system owners, responding to demand response was demonstrated. At the same time, we evaluated the potential of thermal storage tanks in comparison with other methods. The results are shown in this table. Compared to other methods, the thermal storage tank had superior characteristics, and the effectiveness of it for demand response was confirmed. And I would like to introduce studies of Carnot batteries. Japan has been participating in Task 36 to promote the understanding and widespread of use of Carnot battery systems in Japan. Around 1221, NIDO and Japan Science and Technology Agency, or JST, started a project on high-temperature thermal storage systems for the Carnot battery with high-temperature PCM and high-temperature chemical heat pumps. In addition, the Ministry of the Environment has started a large-scale research project on rock thermal storage. We understand that these are the results of Task 36 activities. In addition to the Sasashima Live 24 I introduced earlier, I will introduce 4 examples of thermal storage in Japan. This is an example of thermal storage in district heating and cooling. Tokyo Skytree is the tallest tower in the world with a height of 634 meters. The area, including the Tokyo Skytree, is powered by district heating and cooling and has a water thermal storage tank of 7,000 cubic meters. And Nakanoshima is the business and cultural center of Osaka, and this area is also powered by district heating and cooling, and is equipped with a 2,400 cubic meter water thermal storage tank for cooling and heating. This is an example from the commercial sector. Abeno Harukas is a commercial complex with a height of 300 meters, the tallest skyscraper in Japan. It is equipped with a 806 cubic meter water thermal storage tank as a cold source for air conditioning. And at last, this is an example of industrial sector. Hakutsuru Sake Brewery is a factory that makes sake, Japanese sake, and has an ice thermal storage tank to cool the sake storage tank. And at last, I will introduce HPTCJ YouTube website in English. Here, we post examples of thermal storage. If you are interested in, see later. That's all from me. Thank you so much for your attention.
Well, thank you for this opportunity to talk to you about EIT InnoEnergy, and in particular what we do in the strategic value chains. So let me just give you a short introduction on who we are and what we do and how we do that, and then I'll do a deep dive on the strategic value chains. So we were founded exactly 13 years ago. As actually a result of a public tender by the European Commission that looked for opportunities on how member states could work together to give a boost to the innovation that is needed to speed up the energy transition. So it is a public-private partnership with, and we're a real company. We are run like a real company, so we aim to be able to sustain ourselves financially, and we are quite on that path. We have shareholders from the academia, like Vito in Belgium, that is one of our shareholders, and also KU Leuven, at the Technical University of Eindhoven. Then we have Kolen Industries and the bank ING as the Benelux shareholders, and then about 30 others scattered around Europe. So the aim is to speed up the innovation for energy transition, but also eventually to obviously reduce the CO2 emissions and also make European continent a more competitive landscape, and that has become even more in the picture the last months and weeks because of the IRA measures, and also that's where our strategic value chains play an important role. So the core of our activities is that we de-risk and we reduce time to market for energy innovations. Since our existence, we have scrutinized about 7,000 innovative cases in sustainable energy. We've supported around 450, and today we have around 300 active investments left. So that means that about 150 went belly up. Recognized by many externals as the most active sustainable energy investor. And we're one of the largest climate and renewable energy tech investors in the world. And we're scattered around 6 offices. We have a very strong presence also in Brussels because our interests there, but also such that we can have an influence on regulation and know what's going on. And 2 years ago, we also started an office in Boston. And our activities include 4 things. Number 1 is that we invest in human capital. So with our partner universities, we offer master classes. We produce master students basically, and we offer professional learning services. We do incubation, so we invest in very early stage, usually capex heavy startups. Our first unicorn in that respect, and that was also part of the industrial value chain European Battery Alliance, as our flagship investment is Northvolt, that I'm sure that many of you know. Then we also invest in innovation product development, so that usually takes 3 to 4 years to bring a product on the market, and where we take a cut of the investment and we get equity back. And then the last one, and that's what I will discuss a little bit more in detail in this talk, is that we set up industrial value chains. The first one was the European Battery Alliance. The second one was the European Green Hydrogen Acceleration Center. And we just, I see there's a typo there. The last one we set up is the European Solar Industrial Alliance. So here's some key figures, which I will not go into much detail, and I already mentioned a few of them. So Northvolt was our first unicorn, but we actually have 3 on our record. 3 industrial value chains, 1 battery academy for the reskilling of professionals into the value chain, and other lots of facts and figures that I will happily to share with you at a later stage. So why the industrial value chains? Well, we saw that to reach the objective to have the European continent become more competitive, investing in startups or the product development was not enough. And the first opportunity that we saw was the European Battery Alliance that we founded because we saw the opportunity there that with the rise of demand for batteries, specifically for electric vehicles, and the growing demand out of China, and also the dependence of these batteries on China, we saw the possibility there to jump in. And there, together with the Commission, we launched the European Battery Alliance. Why? Because it's not just about investing in innovation, but it's also having a framework to make those innovations actually grow and industrialize, come to the level like we did with Northvolt, to really have an impact on also the number of jobs that's going to be created, and as such become less dependent on China. For that, we got political support, but I'll show you a picture later on. The second one we did was the Green Hydrogen Acceleration Center, and the last one was the Solar Initiative. But let me first explain again our first one. So there, we saw the opportunity to build business for European companies to grow, and for the possibility for Europe to become less dependent on other manufacturers. So we cover the whole value chain, so starting at raw materials, and there we have supported also, for instance, lithium mines, but also the mining of carbon. And it covers the whole value chain up to including the recycling, which is important because with mining alone, you will still need to recycle your materials that you've used in earlier batteries to make sure that you will be able to have a European-only economy around batteries for electric vehicles. And the business is substantial, so it's around 250 billion a year. At least that is what we thought of around 4 years ago when we started this. Today, I think we are around 100 billion, and in the time after we launched the European Battery Alliance, we saw that we in Europe had already invested more in the battery value chain than China in the same period. So as I said, we got political support, which is important because then manufacturers will see that there's an active framework, but also funding for industrialization around it. It was actually Maros Šefčovič, you see here, this gentleman here, that was one of the first big supporters of this initiative, but also later on von der Leyen adopted the whole idea, and we got public open support for the Battery Alliance. Then the second one is the European Green Hydrogen Acceleration Center, which was an initiative that we decided to start without the political support of the European Commission. That's because the Commission already had a European Hydrogen, the Clean Hydrogen Alliance set up, and we decided for strategic regions to only look for green hydrogen. And what we did there is we built newcos. We build actually whole new companies with strategic investors that are across a specific value chain. The first one we set up, the name is Gravity. We set up was around steel. We're also one of the first investors in H2 Green Steel in Sweden, and we're about to set up. We're about to announce a newco around green fertilizer somewhere located in Europe. We very much believe in the hydrogen economy, but we don't believe in the discussions around the price of green hydrogen. What we believe is as soon as there's a customer that is willing to pay premium for a product where green hydrogen has been used to decarbonize it, we think that is a market. We also saw, by the way, that that was actually the incumbents around the, let's say, oil and gas industry that were leading the discussion about the price of green hydrogen. So it was not a completely fair discussion. Anyway, so also we don't believe, we believe that we should not just make hydrogen for the sake of it. It should actually be used to decarbonize a hard to abate industry, and that's why you see the industries scattered around here. It is not the political support out of Brussels, but we got financial support from Breakthrough Energy. Then the last one, but certainly not the last one that we are going to set up, but we're in talks about setting up the fourth one with the Commission that we will announce this year. But last year we set up another industrial value chain. Again, remember, why are we doing this? We're doing this because we see opportunities for Europe to become more competitive. In this case, for the value chain of solar panels, it is a massive growing market. Well, also because, of course, the rising gas prices, everybody is wanting to install solar power now. So we started there first the European Solar Initiative, which has now been revamped to the European Solar Industrial Alliance, where just like with the European Battery Alliance, we want to reshore the whole value chain. So that is from the ingot casting of the that will then form the input for the wafering, up to including the manufacturing and also recycling of solar panels in Europe. There's a massive market also there. There's quite a lot of business opportunities. So here's another slide on that one, on the size of the market. I think that the audience here knows very well what Biden has announced last year on the on the Inflation Reduction Act. It took some time from our perspective to see that Europe took this as an extremely serious threat. To give you an example, if Northvolt would relocate their existing plant from Sweden to somewhere in the United States, it would benefit 1.7 billion euro bottom line on their P&L. 1.7 billion. Why? Because not only the capex investments is subsidized, but also the operational expenditures, the OPEX is subsidized. So it's massive. It's a massive. So try to convince Northvolt to stay here. So we're happy to see the measures that are being taken right now. And this is obviously also very beneficial to all the strategic value chains that and the parties, the industrial parties that are part of this. This is Mr. Breton, who announced last year the importance of reskilling and also reshoring the manufacture of solar panels into Europe. So, like the EBA, this is politically supported by the Commission. And that's where I conclude my presentation. I'm happy to answer any questions that you might have.
Okay, great. Thank you. Yes, my name is Katharina Gapp-Schmeling. I work as a researcher at IZES, Institute of Future Energies and Technologies, but I'm also a professor at Victoria University in Berlin, and I will talk about the sustainability assessment of municipal heat transformation concepts, which we developed in our project COVA. COVA means municipal heat transformation and is a funded project by the Federal Ministry of Economic Affairs and Climate Action. We started in 2020, and actually we started our field studies in April 2020. So you can imagine that the start was a little bit delayed because in April 2020 you couldn't talk to anyone in the field since we were in a lockdown. What I've planned for the next 15 minutes is I will briefly introduce the project, and then I'd like to talk about the sustainability assessment we did for all our study areas and how we did it and what were the results. And since this is a conference on energy storages, I prepared for today an extra. I looked for the concepts that were including storages and prepared the sustainability assessment of those concepts in the slides for today. So our project COVA Municipal Heat Transformation started in 2020, and we want to know about participants and challenges in typical municipal situations for the heat transformation. We analyzed local supply heat systems, and we wanted to have an evaluation and assessment of technological, economic, legal, and social requirements. And since at least 5 of us are members of the Network for Sustainable Economics for quite a decade now, we decided to do a sustainability assessment to answer those requirements and to figure out how we can evaluate that. So what you see here are our study areas, but I also put them on an additional slide. We combined our study areas into 3 clusters. So we have the industry cluster. The industry cluster has 2 study areas, and the criteria for the industry cluster is that industrial waste heat is used for the municipal heat supply. And then we have the city or urban cluster. So we have urban buildings and infrastructure. Those are 2 study areas in Berlin, one in the east of Berlin and one in the west of Berlin. And we have the so-called existing infrastructure cluster, which includes also 2 study areas, one in Turin, so here in the middle of Germany, in the heart of Germany, and one in at Saarland in Saarlouis. The criteria for the existing infrastructure cluster is that you have a small town building structure and you have a quite old existing heating grid. network. So we have to deal with that, how to make that fit for future, fit for 55, how to change that. And in order to reach climate neutrality, we do not want to only reach a carbon neutral heat supply system. We want to have a look at all three dimensions of sustainability, because from our point of view, sustainability always tries to reach for sufficient standards in all three dimensions: ecological, economic, and social, in order to stay within the natural boundaries of our planet. So what we did to come up with a sustainability assessment, we combined different criteria. I will show you how those criteria worked for one example, and these are our ideal typical heat supply solutions for Kova City. So this is just a fictitious example to explain the methodology. And in our fictitious example, we have a natural gas operating heating grid. So this is what you see here on the top. The other concept includes 70% solar thermal systems and 30% natural gas, 100% pellets, and what we called a future grid, 25% solar thermal power systems, 60% alternative heat source, waste heat, and 15% pellets or biomass as peak load. What you might already recognize is that for each of the concepts, I've given the GEMIS process. GEMIS is a software tool where you can calculate carbon emissions and other ecological footprints. So we use that as a proxy to evaluate and assess our concepts. But how did we start, or how did we come to our sustainability assessment? How did we choose the criteria? As I already mentioned, some of us have been a member of the Network for Sustainable Economics for quite more than a decade now, and the Network of Sustainable Economics works with a target system of a sustainable economy. The target system differs slightly from the Sustainable Development Goals. The reason for that is that they kind of invented their target system in 2009, so way before the Sustainable Development Goals. And from the perspective of the members of the Network for Sustainable Economics, in the Sustainable Development Goals, there are some indicators missing. So, for example, the indicator on price stability. We don't have that in the SDG indicators. So we took this target system and combined it with the Sustainable Development Goals. You probably all know, 2015, all member states of the United Nations agreed on 17 global goals, which should be reached until 2030. So we took the goals from Sustainable Economics, linked them to the SDG, and derivated quality goals that we need for the heat transition and operationalized them into criteria and indicators. And you will see in a minute how that worked and how we used the indicators to evaluate and assess the part that our concepts might improve the situation in a sustainable way. It is good that we linked it to the SDG because most of the companies that produce energy or supply heat systems, or even municipal companies, will have to report their sustainability indicators starting 2024 at least. You probably already heard about the Corporate Sustainability Reporting Directive, CSRD. It's a new directive by the European Union, and all companies that have more than 250 employees have to report on sustainability indicators starting the next year. So if you include a sustainability assessment for the projects you're planning, then of course you already know which indicators will improve during the years to come when you implement the project. So we had 5 ecological indicators, and the ecological indicators, I will only explain global warming. Of course, we want to limit global warming, and our target indicator is greenhouse gas emissions in kilogram carbon dioxide equivalents per megawatt hour. For the economic dimension, for example, it's the challenge, a lack of sustainable products. So what we need is an uninterrupted security of supply. You don't want to freeze during winter. So therefore, we need a redundancy. And for example, in the social dimension, we also have 5 goals. We have 5 indicators, and one indicator is the conflict potential of the resource used. So here we see the sustainability assessment of the developed concept I've shown you just a couple of minutes ago. And what we see is that each of the concepts has its strengths and weaknesses. So if you look at the part 1 here, rating 1 means this is a good rating, this is a strength, and if something is over here, it's a rating 5, so it's a bad rating, this is a weakness. And what we see is that there is not one concept that has strengths in all indicators. So what we want our stakeholders in the projects to do is to take an informed decision. Make an informed decision to know what are the strengths and weaknesses of sustainability in which indicators for the concept I've chosen to implement. I will give you some focal points on 3 indicators. So the first one is the assessment of greenhouse gas emissions. What we calculated were the greenhouse gas emissions using the GEMIS software. And here you see our rating grades. So grade 1, an A, is if you have less than 20 kilogram carbon dioxide. This is within the whole supply chain. So it's not only the direct emissions, it's also the indirect emissions. And what we can see is from our concepts in the first step that if you have a look at that, 100% pellets, since if you burn the wood, it's only direct emissions, but before that they have been combined in the wood. So that's why it's rating 1. The future grid has a quite bad rating with the current German electricity mix. It will have a rating in stage 1 if we have a full renewable electricity mix. This is because for future grid, we use a heat pump and we use electricity. For the redundancy, it's important that you have more than one heat source. So if you have, for example, 150 apartments to heat, and one of your boilers just fails, then of course the apartments will get cold, and so you need more than one to make sure it's redundant. Or for example, if you don't have any more gas supply or anything. So what you can see here, the pellet concept is quite bad because we only have one boiler. However, for the future grid, it's quite good because we have another heat source, we have a heat pump, we have solar thermal power systems, and we also have a or might have an additional boiler. So the risk that you have to freeze is quite low. And last but not least, let's have a spotlight on the conflict potential for the resources used. What we calculated was the 3-country concentration of imports. So in 2020, more than 90% of the German imports of natural gas came from 3 countries only. So this is the concentration. Of course, we know that changed now. And what we also did, we calculated the weighted 3-country conflict risk. So there are world governance indicators by the World Bank, which tell you about the conflict risk of certain countries. And we looked that up for those 3 countries, weighted it with the import quota and calculated for it. So what you see with natural gas, these are the numbers in 2020. We did that in 2021. So before the war started. And when I first presented that slide in December 2021, someone asked me if I'm really sure I want to rate natural gas that bad. And I was really sure, because what you could see is that for natural gas, we had a high conflict risk. You could already see that in the numbers. Of course, I know today no one is surprised by that chart. So we have for gas, we have 5. And of course, for local, we have a better rating. I will very briefly, because I guess I'm running out of time, just show you some of the study areas, just in 2 minutes. Is that okay?
Absolutely, Kay. We have some buffer at the end, so don't worry about it. Yes.
Okay, okay. So I brought for you the industry cluster. In the industry cluster, we have local partners who are producing certain products. So for example, Gapp-Schmeling produces steel, and DMK, Deutsches Milchkontor, produces cheese. And to produce cheese, they need heat. And when they melted their steel, they still have some waste heat. So what we had a look at is how to transport those heat. So we had industrial waste heat, also waste from residual wood from Wiedemann, because they're producing desks and furniture, and biomass heating plant. We did 2 concepts with high temperature and low temperature, and we used a heat storage there. So the industrial waste heat goes to the heat storage, and then it goes to DMK to produce cheese to be used as process heat. In the scenario with low temperature, you might need an additional natural gas boiler to come to the high temperature again. You might ask yourself, okay, well, then just stay with a high temperature, but we have 2 kilometers to cross between the steel factory and the milk factory. And so for the local municipal heat grid company, it is difficult to build a high temperature grid. So that's why we calculated both. And what you can see is that actually, if we look at the sustainability assessment, the high temperature concept is even slightly better. Although it is difficult to build a high temperature grid, looking at the sustainability indicators, the high temperature solution will be more sustainable. I will briefly have a look at another study area. It's in the middle of Berlin. Our local partners were the HPTCJ. HPTCJ is a local, quite large company for renting apartments. They're state-owned, so it's not a private company. And the municipal actors were our local partners. And what we calculated here in concept 1 is a solar thermal system with 1,300 square meters and a seasonal underground storage tank of 3,600 cubic meters. I hope you can see my mouse. The storage tank would be here. It's an underground storage tank. Nevertheless, it would be above the usual leverage, about 1 to 2 meters. So if you look out your window, if you're living in the first apartment, first floor, and you look out your window, you will see that tank. And that was actually the reason why the HPTCJ didn't choose this concept. even though it's a good storage concept. If we store the solar power, the solar thermal power, then after refurbishing and improving the energy efficiency with the storage tank, you could have a renewable shares of 67% to heat 150 apartments. Concept 2, a smaller energy storage, only 200 cubic meters. And you see, we would need an additional wood pellet boiler, and only with the additional wood pellet boiler, we would come to a similar part of renewables. Last but not least, what's actually been chosen is concept 3. And even though we calculated for an energy storage, the Hovoge didn't pick the storage. So they picked the concept without the storage. What they're going to do this year, they're already looking for a company to build it, is a heating grid, and they're using waste heat. So here's a wastewater pipe, and Berlin citizens like to take a hot shower. So this one over here has 15 to 20 degrees. And this is a good heat source for a heat pump to then have a high temperature heat pump to heat the building. What we can see here, actually, concept 3 has a lot of strength, even though it doesn't have an energy storage. So please don't think my conclusion is we don't need an energy storage. I think we do. However, what you see is that you have to look at the particular project to decide if you need an energy storage and which one actually you need. So thank you, and I'm open for questions.
Thank you very much. And yeah, I think you're absolutely right. Just because most of us are working on energy storage, it doesn't mean it's always the best solution, even if the heart is on the science and whatever, but it always has to be the one which is the best of all the aspects. So many thanks for your work. So we can go to the question part now. I'm not sure if there is, so if you're in the audience, you can raise your digital hand and I can unmute you. Yes, we have one. Oh, 1 second. So I can if I'm fast enough. So please, you can ask a question.
Yes, hello. This is Robert from the Netherlands. What I was wondering is, I saw the few concepts, but there are also concepts with solar heating in the combination with large thermal storage, and then a day buffer. And between the day buffer and the large solar storage, there is a heat pump. And this heat pump can work on the times of the day and in the year where the electricity is cheap or very cheap, or maybe even you get money when you use electricity. And I miss this concept going through these things. Plus, storage can also be fully underground. I could provide you with some examples from the Netherlands.
I think this question goes to me. Well, for one reason why we didn't look at that concept is that in each of our study areas, we had local partners and we discussed with them what concepts to have a closer look at. So as you might imagine, if you calculate 3 different concepts and also calculate for the dimensions, that's quite a few work. So I cannot do 10 for each study area. And in particular for Berlin, we had troubles with the underground. So we are not allowed to go deep into the underground because this is a water protection restricted area. So what we
How deep is that? How deep is that?
They said only 3 or 2 to 3 meters. And so because it's a water protection area, what we actually wanted to do and didn't conceptualize were geothermal power. So we are in an area in Berlin where we know that geothermal power would actually be possible, and it would be enough to heat those 150 apartments. However, the administration, the municipal administration right in front said, that's not possible. We will not allow this because this is a water protection area. You're not allowed to go into the ground with anything that heats the ground or to get anything from the ground. So there was one reason why also the HPTCJ pretty soon said, well, that's too difficult to discuss with the administration.
And then the concept of the air to water heat pump, was that considered?
It's not an air to water heat pump. It's can I share my screen again?
Of course, yes.
So it's a heat pump, but it uses the waste heat of
Yes,
the
I understand.
wastewater.
Yeah, I saw that. But in the other scenarios, you still use gas boilers?
Well, we calculated that at the end of 2020. And since the HPTCJ pretty soon decided on the concept 3, we didn't recalculate the other scenarios because we had other focus points in the project. I know today you wouldn't calculate for a gas boiler. From my point of view, I did not want to calculate with a gas boiler in the first place.
Very good.
So as you know, if you have a project and you have a stakeholder, I mean, we could show that gas boiler is a bad idea, and if that's what the project was good for, then at least we got that message across.
Okay, thanks.
You're welcome.
Okay, so many thanks. I will take one question from the chat now, maybe a follow-up question to you, Katharina. It's asked, why have the pellets been considered totally renewable?
Because in the sustainability assessment, we said if you use pellets and they are certified from a regional supplier and to be renewable, then that is possible. We discussed that with our with Bernhard Wern, actually, who is our expert on forests at IZES. And since around Berlin there's Brandenburg, and we have a lot of forests in Brandenburg, and actually at that time in Brandenburg we had the problem that we had too much waste wood. So that was reason to say, if I leave that wood in the forest in Brandenburg, I have a huge problem because it will not bind carbon dioxide. It will just catch a wildfire in the summer. So we had that problem actually last year in the summer because the administration wasn't quick enough to pull out the rest wood out of the forest. And 2 train stations away, a city called Belitz here, they had to close the railways, they had to close the city, they had to evacuate people due to the wildfires. So yes, not all pellets are renewables, but if you use them from a local source and you have a close look if they're certified, then we can discuss them as renewables.
Okay, thank you. So this might also leads me to the follow-up question. Are the metrics, is the evaluation somehow weighted? Because for the woods, for example, maybe it's the best example, like, okay, but maybe I'm somewhere where I'm very rural, there is not a lot of woods, there you don't have any waste wood from any industry. Can I say it is maybe not so CO2 neutral?
we defined that you can only calculate the wood as carbon dioxide neutral if it is certified. If not, then not. And what you actually do, I mean, we picked those data from the GEMIS software. So there you have different kinds of wood you can put in the process. And if I put in certified wood, then I get out a low carbon dioxide emissions. But if I put in not certified wood, or maybe wood that comes from, I don't know, Brazil or so, then of course I would get a higher carbon footprint. Nevertheless, in most of the concepts, I've shown only a couple. We actually did almost 30 concepts in the project. And in most of the concepts, if we use wood, even now after we don't want to use natural gas anymore, we only use it for the very cold days as an additional source. So because we have areas where it's not so easy to refurbish the buildings. So, and then I can work with a heat pump, but on very cold days where we have -5 degrees or -10 degrees, which we had this winter, the heat pump might not work properly, or if I have a lot of heat pumps, the electricity grid will get into trouble. And for that situations, we calculated with an additional boiler for pellets.
Okay. Thank you very much. So I think now there are some, I think there's some follow questions, but I just want to give the other question is some time to have the question answer as well. So we have one question from Kamel Human to Jacob. So the question is, if PV is if it's so it's on its own, and as the opposite, there's also PVT, so also the thermal part involved, and it sounds like a waste of opportunity. So the question is, have you considered also, for example, concentrated, so CST or PVT in the concept?
No, we have not. This is outside scope. So this is PV only. Interesting remark. I think that many investors, including the Commission, thinks that reshoring the production and recycling and the wafering and the slicing to Europe is a massive opportunity. So I don't really understand the comment here. No, but it's outside scope. But that doesn't mean that we don't think it's a good idea to also do PVT. Mm-hmm. But this is just something that we cooked together with the Commission, and is born from the fact that everything is done out of China. So it's got nothing to do with that we disregard or disqualify PVT. But we have to start somewhere. So
yes,
that's why.
Thank you very much. Maybe if there's more detail on the comment or on the question, feel free to ask directly, and then you can discuss. Maybe there was something between the line which we just didn't, or I just didn't understand.
Well, I read the same, yeah.
Okay, thanks. So I will give one of the audience. So Herbert, you were first. Should be able.
Okay, yeah. Thanks. Yeah. Okay. I had another question for Katharina. I saw one of the three main lines in research was also related to waste heat. Now, at one hand, I can imagine that waste heat is an opportunity to supply to district heating. On the other hand, the industry itself has to reduce its CO2 emissions, and therefore also the amount of waste heat produced. So how do you take into account the time-wise, the availability of this waste heat? What do you assume there?
Okay, we discussed this in the project. In particular, what we need to keep in mind is that we looked at particular study areas. So the concepts I've shown, besides the fictitious example at the beginning, the concepts I've shown are real-world concepts for real-world cities. And in those particular cities, there was a project before to reduce waste heat in those factories. So they already lowered that, and they already use their waste heat inside the company. And then again, they still have additional waste heat. Or in case of the steel factory, we've been there on a research field trip. And for me, as a sustainability economist and not an engineer, that was quite impressive to see the steel melting at 1,600 degrees Celsius. And if you want to produce steel in Germany, I don't know any lower temperatures you can do that. Of course, you can use other energy to produce the heat. So for example, maybe hydrogen later on and so on, or maybe also other carbon neutral fires. Nevertheless, the waste heat will still be there. And so what we looked at this concept is to use that waste heat for the best. And we could use it actually for process heat to produce milk and cheese. Well, milk and cheese is not what you can also ask, well, but we need to eat less milk. Yes, of course, we do. But it's a solution for that specific particular area. And I think we can learn for some other areas something about it. But of course, you're right. If you have not reduced your waste heat to a point where you cannot go any lower, then it's not the first question to look where to use your waste heat. You should first reduce and then recycle.
But given, I fully agree to you, so thank you for this answer. But at the same time, this company, I suppose they will have to develop their own plans on how to reduce their CO2 emissions up to 2050. And so I assume that they are considering changing technologies. They have some planning on how long this waste heat will be available, or it will change over time. Do you include such information?
We included such information, but in this case, they already work with an I only know the German term. I'm sorry, Elektrolichtbogenofen. So
is it electric arc furnace?
Yeah, probably electric arc.
So it's scrap melting, you mean, or?
Sorry?
That's scrap melting, you mean, or what?
Yeah, for the melting process. So and for that part, they of course they want to use renewable electricity, and for the other parts, they're using natural gas today, and they want to change that. But for the melting, you have 1,600 degrees. I'm not the engineer, I'm the economist. So if you tell me if you tell me it's possible to melt steel below that, I'm happy to learn.
Well, we definitely can go into detail over here, but I'm not sure if that's needed now. In general, I think what we see is that often there is a lot of pressure on industries also to make their waste heat available, and it's for them a relatively easy solution if a municipality knocks on the door and asks, well, if we put a district heat network over here, can we use the waste heat? But we think indeed it's very important that first the industry tries to minimize the amount of waste heat they produce themselves.
Totally agree.
Yeah.
Totally agree, and that's what they did. A minor addition to that, within the project, we also talked to ISO 50001, and they implemented in their FAQs, they will publish this in a couple of weeks, that if you minimize your waste heat as a company, so there's no other way to minimize it further, and you then give your waste heat to local district heating, then this is an improvement regarding the ISO 50001.
Yeah. Okay. Okay. Yeah. Thank you for your answer.
Okay. So maybe if you have still some issue to discuss, maybe you can change your details, and I mean, still it's important to stay in touch and to see all the sites. It's impossible for one person to know all the what's going on. It's too complex anyway. So it just shows how important it is to stay in touch from the different fields. So considering the time, I would just give the one question from the panelists, Geoffroy, the chance. So you have a comment, please.
Yes, thank you very much. It's just a few comments with regards to previous questions that have been asked, and I would like to put my 5 cents into the play. But thank you very much for all the other presenters. With regards to the first question that was asked about the thermal energy storage, the small thermal energy storage, and the option 3 that was chosen, I think it makes sense to see such a conclusion, because as I was presenting, large thermal energy storage makes more sense from an economic sense. So for smaller systems such as the one you were showing, it can very much be that it won't be the right option to have a thermal energy storage. But the right conclusion here is to say that you have to make a specific study to identify what is the best system solution. And what is interesting in the approach that you've shown is this sustainability assessment that comes on top of just pure economics. My second remark was with regards to the question of PV and PVT. Before working at PlanEnergi, I was working at a startup called Dual Sun that produced PVT in France. And actually, most of the PVT worldwide is produced in Europe and is actually in France. So with regards to having a local production, this kind of sets the tone. And a PVT panel is a PV in the front and the heat exchanger in the back. But the PV cells are produced in China today. So if you solve the issue of producing PV in China, in Europe instead, then you have 100% European PVT produced, and it also solves your issue. So I think that's something to add, even though it's not in the scope of what you're doing, Jacob. I think the answer is already seen, that PVT already makes sense at a European level. But thank you very much, Jacob, for the work you're doing at EIT. I was also having a startup supported by the incubator program, so pre-incubation program. So I like very much what EIT InnoEnergy is doing. And my last comment, and then I will have covered actually the 3 presentations of my colleagues here, to Takahide Tokuda. Japan is not in our distribution list yet for the task 39 results. So I'd very much like to know if you're interested in receiving the reports and the documentation that will be produced in our task. And if yes, please, if we can share contact information, that would be great. Thank you.
Thanks a lot. So you wrapped it up for all the other panelists. So I will need a couple of minutes at the end, but there's one more question. Maybe we can answer it in short, because it seems like it could be answered shortly. The question is, what's the advantage of complying with the ISO 15001?
Well, it's 50, not 15. So 5001. 50,000, and this is an ISO for energy management systems. so like the 14,000 one for environmental management system, just for energy management system. And due to some European regulation, it has some advantages for companies to be certified for that management system. So you can save in some member states of the European Union, you can save on energy taxes, because if you have an ISO 50,001, then you have to improve your energy efficiency and reduce the energy you use every year. So you have a continuous improvement cycle. You have to prove that every year. And if you do that, then you might get tax reductions. So it's important for the companies to find ways to be more efficient.
Thank you very much. I think, I guess with this it's answered. I propose. So then I would use the last minutes to thank you all again, to all the speakers, the last 2 days, and the listeners as well. Was, I guess, quite a nice start of the online Enerstock. So the first time, looking forward to the next time, I guess in 3 years or so. We always had around, now a bit less, but between 70 and 100 listeners, I guess depending on the time shift as well. So yeah, and it could be, to wrap it up, at least in my opinion, Christoph, if you have a different experience, you can add. I think there were a lot of things were really strongly in discussion. So not only the technical things like technology to the low TLR should be supported, and we need big pilot projects and so on, but also especially when it's interdisciplinary, like what we just have seen about the sustainability assessment, and also the economics, and just to work in different fields. It always gives a lot of discussion, because for one expert it's impossible to know all of this, and I think this, in my opinion, is the key to make it successful step to be quite fast and still sustainable. Not sure, Christoph, if you have any other notes.
Well, I agree with what you said. So, and I'm quite happy about the conference, and the concept worked. So to look at energy storage from various perspectives, to cover different technologies and different perspective in one session, that at least to me it was quite a useful concept. So your feedback is highly appreciated. If you would like to give us some feedback afterwards to the content, but also to the way of organizing the conference, this online conference. So please feel free to write us feedback whenever you like. Yeah. Okay. Geoffroy, I hand over to you again.
Thank you. So I will share my screen again. So this was now, and there should be another slide. Just to wrap up with some information and a bit of advertisement. Well, as you know, this is planned by the Energy Storage TCP. And in case you not already part of the ESTCP family, or I guess a lot of you are working on any tasks, but if you want to contact, you can go to the ESTCP webpage. Maybe, I don't know, Christoph or Jan, you can maybe put it into the chat for all. If not, I can do directly. And you can also sign up for a newsletter, which is every couple of months. You can sign up simply on the webpage as well. And here you see we have a couple of them already. I mean, the last ones are still available. You can have a look at them if you're interested in. Another thing which is happening is the ESTCP on seminar, which is started also last year. It's more or less monthly. Lately was because of this organization, not monthly, but still. So we try to do it every month, at least every second one. If you have any topic you might want to present, or if you see there is a lack or something, feel free to write as well. I just had a lot taken away, which I might write to some people if they want to give more time and have on seminar, because there was a lot of feedback or reaction. So I think it's important to move on in this direction. And another thing, quite nice, I'm happy to make some advertisement for this as well. So this is the online version of the Enerstock, but there will be next year a live version. So hopefully it's live. The last Enerstock was not live, unfortunately, but this one is planned to be. It will be in France, in Lyon. So in June next year, from the 5th to the 7th, we have some details here. This is the venue in Lyon, where it will take place, the Congress Center. And there are some details, maybe more the focus of you. Just you can write it already down. There is already the deadline for the abstracts. I think it's not a homepage now already, so no pressure. And there's still a couple of months to go, but maybe to keep in mind. Probably in the next newsletter, I could imagine there will be some information, I guess. So don't get nervous if you don't find anything now. But to know, in May there is a call of abstract, and here's the rest of the schedule, what to hand in and when. And yes, so maybe there's the possibility to meet in live next year, then on Enerstock directly. If not, thank you again. Maybe keep in touch with all the topics you like to. If there are still questions, feel free to write us. We're happy to answer and to connect.